Good morning. So what we're going to do today is we are going to summarize what we just learned with that Desmos. So with that being said, we are going to take some notes about our triangle congruence theorems. And it is the 17th. Yes, it is the 17th. So, if that's the way, it's your triangle congruence theorems. So I'm going to go like this just because this is how I make my notes, if you remember. So the first one we're going to talk about is S, S, S. And that means side, side, side. So for side, side, side to be a triangle congruence theorem, three sides of one triangle are congruent to three sides of another. So what that would look like for side, side, side to be true, and this is cool with tick marks because no matter how crappy my drawings are, these tick marks mean it's true. So these are my two triangles. Right now they don't look congruent. But if I say these are my tick marks, if I say that this side is congruent to this side is congruent to this side, and this side is congruent to this side, they mean that these two triangles are congruent by side, side, side. So for the next couple that I'm going to do, order matters. So I'm going to put that order matters. And you're going to see why order matters for these next couple. So we're going to start with SAS, which is side, angle, side. And for this one, this is if two sides and the included, and included means in between, angle of one triangle, and then I'm going to put dots, and then is congruent to two sides of the included angle of the other one. So that is just what it repeats, because I'm lazy and don't feel like writing it out, and I doubt you want to either. So the reason that order matters, I'm going to draw my two triangles again, is because we read the triangle from like we would be reading in order. So just like the name order rule, the order matters, reading our triangle matters as well. So if this is my first side, then the angle has to be the next angle I see. So this would be my angle, and then the other side would be the side right next to that. So see how it's in between those two sides? It's our included angle. And that would be congruent with that. I'm going to start drawing the pictures a little bit trickier for the other ones, but they'll mean the same thing, and you'll see what I mean when I do that. So that's side, angle, side. And we already discovered all these on our own for our Desmos. The next one we discovered ASA, which is angle, side, angle. So angle, side, angle is if two angles and the included side of one triangle is congruent, then and the same of the other. So that's that same thing. So these are the opposites. So side, angle, side, and angle, side, angle. And they both mean that triangles are congruent. So say I have these two triangles, and I have this angle, this side, and this angle. Notice how the side is in between those two angles. That could also mean this is congruent as well. So notice how the tick marks matter. So I still have an angle with one tick. I still have one tick mark on the side, and I have two ticks for this upper thing. That means even though they're not necessarily in the same place, they're still congruent. One triangle is just rotated in a different way than the other. Our very last triangle congruence theorem is angle, angle, side. So angle, angle, side. You could also see this as SAA. They're the same thing, but you normally will see it as angle, angle, side. I don't know why. So this is if two angles and the non-included side of one triangle is congruent to the two angles and the non-included side of another triangle, they're congruent. So what this one looks like, sorry, this is caught on this. So I'm going to draw my two triangles. So what this one looks like, so say I have this angle, and then I have this angle, a non-included side, so it's not on the inside, it would be on the outside here. So I have an angle, and a side. If it's congruent to this other one, let's say this angle starts here, and then I have this angle here, and I have that there. Note, if I drew my triangle, this red one is going to be wrong. If I drew it like this, yes, it has two angles and a tick mark, but the tick mark is located with this one little arc here. To be congruent, the tick mark has to be on the side with those two arcs. So you have to pay attention to where the tick marks are. And it's a lot of paying attention to detail. The very last thing I want to talk about really fast are those two things that were not congruent. So not congruent. So these are not congruent theorems. They can be congruent at points in time, but they are not theorems. And the two non-congruent theorems are angle, 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 because we can get like infinity triangles out of this. We just keep making our triangles bigger and smaller. Our angles stay the same, but they're not congruent because our sides are going to be different. The other one is I'm going to write it as side, side, angle. If you write it backwards, that's a swear word, and you can't swear in math. So obviously this can't be one. But the real reason, the mathematical reason, is because you can make two different triangles from it. So you can make the triangles. So let's say this is one triangle. You can also swing this leg around, and you can make it here as well. So you can make two different triangles. And we kind of were playing around with that when we were moving our K slider. So that's just a summary of what we were working on. So I hope that you finished your Desmos. If not, go back, finish your Desmos.